We have developed a high-performance equipment with silicon carbide technology that increases the bandwidth and optimizes the device performance. But let's start from the beginning. Silicon carbide is a semiconductor material discovered some years ago. However, its use in power electronic application is quite recent due to the cost of the material substrate and other manufacturing issues that have not been resolved until recently. In power electronics, the most interesting power devices based on SiC are diodes and MOSFET transistors, where they present the following main advantages over traditional silicon IGBTs. First of all, high insulation strength. Secondly, faster switching time. Also lower switching and conduction losses. And finally, higher temperature withstand and better thermal conductivity. All these properties translate into a smaller and more efficient power devices. At Cinergia, we set ourselves a challenge to develop a device with silicon carbide technology. It was an exciting bet because it was a very new technology on the market and nobody was doing it. As you can imagine, this process required a great effort from the whole Cinergia team. So, after many months of work, we can finally announce that we have developed the new equipment with silicon carbide technology. A success that opens the doors to new projects and new development challenges in Cinergia. Now it's time to take a closer look at the equipment and discover its features. Let's go! The creation of this product is based on the replacement of the IGBTs by SiC MOSFETs. One of the main differences of the new equipment is the increase of the switching frequency. So, let's talk about the benefits of the higher switching frequency. In switched power converters, as the converters from Cinergia, the power semiconductors work in two states: completely off, that means near zero current, or completely on, near zero voltage. While transiting from one state to the other, the voltages and currents do not change immediately, and therefore are both non-zero during some short time. This short crossover of current and voltage generates power losses in the semiconductor at each switching cycle, which happens at 15 kHz. The main benefit of the SiC MOSFET is the faster switching time, thus reducing the current voltage crossover duration, and therefore reducing the losses at each commutation. As the losses at each commutation are reduced, the switching frequency of the SiC MOSFET can be increased without increasing the total losses, or even reducing switching losses compared to the standard IGBT. When the switching frequency increases, the output filtering stage can be reduced. That is, it needs less attenuation for the same output ripple. This implies that the cutoff frequency and also the resonance frequency of the filter can be higher, allowing us to increase the bandwidth of the control and thus the bandwidth of the whole converter. A higher bandwidth of the converter translates into a better capacity to control fast-changing and high-frequency signals, which provides the following direct benefits for the user: a higher slew rate of the output currents and voltages, which is especially noticeable when the equipment is used in power amplifier mode. But this is also very useful in any other mode to maintain the given set point while supporting fast transients and disturbances from the device under test. Additionally, the voltage frequency limit of the device is increased, which allows fundamentals of higher amplitude and frequency, and more harmonic contents. With the new equipment, we can generate fundamental frequencies up to 1000 Hz at 230 volts. Another benefit is an improved control of harmonics up to 5000 Hz. Standard equipment of the same power that uses IGBTs has a switching frequency of 15 kHz, which falls in the higher part of the human audible range, but it's still audible. This frequency normally represents a compromise between the audible noise and the switching losses of the traditional IGBTs. Thanks to the SiC MOSFETs in our equipment, the switching noise is increased up to 60 kHz, making the switching completely inaudible. Even more, due to the reduction of power losses of the whole equipment, the cooling fans work at low speed most of the time, making the equipment even quieter. Thanks to a balanced configuration, we also improve in the following aspects. Despite the reduction of the output filter, the increase of the switching frequency is high enough to significantly improve the switching ripple of current and voltage. This is thanks to an equilibrated selection of hardware elements and control adjustment. SiC MOSFETs are much more efficient than the IGBTs, not only regarding the switching losses, but also the conduction losses. Additionally, because the power filter is reduced, its losses are lower. Lastly, the MOSFET incorporates a more efficient antiparallel SiC diode that also reduces the losses. All these three effects translate into a higher efficiency, despite that the switching frequency has been increased 4 times. Thanks to the use of the SiC MOSFET at both converters of the back-to-back configuration, the peak efficiency of the whole system is boosted above 94%. The SiC MOSFET used in the converter also includes a SiC diode in antiparallel, which has better electrical characteristics than a standard silicon diode, specifically lower switching and conduction losses. On one side, this helps to reduce the global losses, but on the other, it allows higher recirculating currents, which is a limiting factor when working DC at nominal current and low voltages. Thanks to the SiC diode, our equipment now has the same current capacity in DC as in AC mode. In conclusion, we have developed a new device that enhances our actual all-terrain unit with a 60 kHz commutation frequency, low ripple and faster transients. This equipment is the perfect solution for all research applications. Our GE+EL AC-DC device with SiC technology represents a whole catalog in a single cabinet, with all the features that defines us: robustness, efficiency and quality. By adding this cutting-edge technology, we enhance our product line to higher performance. Welcome to the silicon carbide era.